Ringer, and we're going to be on page 613. Today we're talking about more pyramids and cones like we did yesterday. We're also going to do lesson 16. We're going to skip 15. So we're just going to kind of hit some things. Remember, the pyramids and cones is just like the cylinder and prisms, but we take a third of it. 3 of those cones can fit in one cylinder with the same radius and same height. So we're just going to do a little bit more. But before we start there, let's look at yesterday's cool down. It says, Diego and Karen used different strategies to find the volume of the rectangular pyramid. The measurements are given in centimeters. So we have a 10 by 12 base, and the height is 8. It says, Diego said, I drew a prism that had the same base and height as the pyramid. I found the volume of the prism and divided by 3. Karen said, I used the formula V equals 1/3 capital B times height. Do you agree with either of them? Explain your reasoning. Well, Diego's works because if you have a prism with the same base and the same height, then 3 of these pyramids would fit into it. So you can define the volume of that prism and divide by 3 to get the volume of this pyramid. And this is actually the formula that does that. Here's the volume of the prism, and then when we multiply by 1/3, we're dividing by 3, and we get that. So some of you is like, yes, I agree. That doesn't make sense. Or who do you agree with and why? Do you agree with either of them? Explain your reasoning. You have to answer. Okay, if you say yes, I don't know who you agree with. You have to tell me which ones you agree with and why. Then it says calculate the volume. So if you said yes, I agree with either one of these, then you should be able to do this, what it says. Either take the volume of the prism and divide it by 3, or do 1/3 base times height. Some of you didn't give me the right answer because you just weren't paying attention. So we're going to do 1/3 capital B times height. This is your rectangle base. So capital B of that, the area of the base is length times width. Then we're going to multiply it by the height, divide it by 3. So we're going to get 10 times 12. And then times 8. So get out your calculator, do 10 times 12 times 8, and divide that by 3, and you get 320. Does it say centimeters? Because right there, centimeters cubed. And I think it actually gave you a box for that. So be careful what you are doing. All right, page 613. It says volume matching. Here is a pyramid, which, if either of these solids has the same volume as the pyramid. So let's just look at this and see which one has the same thing. Let's do it. So this is a rectangular pyramid, capital B times H, and it's divided by 3, or 1/3 times that. So length times width times height. It's 5 times 4 times 6 divided by 3. So 5 times 4 times 6 divided by 3 is 40. Now, and it's units cubed. Now, I need you to find the volume of this, the volume of that, and see which one matches, if any of them does. This is a prism, so you're on A, you're just doing length times width times height. Actually do it. Don't just write length times width times height. Do this problem. And then this is it's a right triangular pyramid. So to find capital B of any triangle is base times height, 1/2 of that, times the height of the whole thing divided by 3. So 0.5 times, here's your base and height, and here's your height of the whole thing. And then divide by 3, see if that's the same. All right, let's look at this second one. Calculate the volume of each solid. Round your answers to the nearest tenth if necessary. So the same thing, all I want you to do is, we're not going to worry about number 2. I want you to calculate these. You're going to do, these are all cones and pyramids. So you're going to use this. Capital B means the area of the base. So you have to figure out what the base is. This is a square. So capital B equals side squared. On this, it's a circle. You should know these. This is a right triangle. So capital B is 1/2 times base times height. And this is capital B. So you don't have to figure out capital B on that one. Do those. I need answers and not just what's written right here. We're going to do this one. A baker is making a pyramid out of chocolate for a special display in a store. The baker has 20 pounds of chocolate to use, which is about this. Cubic inches. This is our volume, guys. Okay. The pyramid must be 15 inches tall. The baker needs to decide how large to make the base, which can be any shape. Draw and label the dimensions of 2 different bases that would work. So let's say it's a rectangle. This is a pyramid. So we're going 1/3 capital B times H. So 1/3 times length times width times the height. And we know what the volume is. So we know 720 equals, and I'm just going to do it like this, capital B times, what is my height? It must be 15 inches tall over 3. So now we're going to solve this for capital B. So capital B, so first we got to multiply this 3 off. So 3 times 720 equals this. Now we're trying to get B by itself, so 15 is multiplied by it, so we got to divide it. So divide that by 15. Now, how could we make a rectangle that the area would equal 144? I don't know. Let's put 2 in here. 2 goes into 144. How many times? That would be a 2 by 72 rectangle. Okay, give me another one that would equal 144, another rectangle. So there's your 1. Give me another rectangle. You don't have to solve it anymore. You just have to find a rectangle that if you multiplied its length times width, it would give you 144. We're going to move to our purple pages. It says a pyramid has the height of 5 inches. This is a pyramid. Has the height of 5 inches and the volume of 60 cubic inches. Select all figures that could be the base of this pyramid. So we know that for a pyramid, it's this. It may be easier to think about this. Capital B means the area of the base. So we know the volume is 60. And we know what our height is. Our height is 5. So we are going to solve for capital B. So we take 3 and we multiply. So if we multiply this, that cancels out. That gives us 180. And now we have to divide by 5. And you get 180 divided by 5 is 36. That's capital B. It says for us to select all figures that could be the base for this pyramid. Capital B means the area of the base. So you need to then find the area of each one of these and see if it equals 36. So I'll just do one of them, a square with a side length of 6. Well, we know that the square is s squared, which would be 6 squared. That equals 36. Since it does equal 36, this is one of them. You do the rest of these and see which one equals 36. On number 3, it says select all the solids with the volume of 40 cubic units. You need to find the volumes of each one of these and see which ones are 40 units. Remember, for cylinders and prisms, it's V equals BH. And for cones and pyramids, it's V equals 1/3 BH. So that capital B equals area of the base. You have to figure out what the area of the base is, multiply it times your height, and sometimes we divide it by 3. So I want you to do every one of these. And let's look at number 4. The volume of a pyramid is 50 cubic units. This is the volume, and this is a pyramid. Okay, and it says the base is a square with the side lengths of 5. What is the height? So we know that it's 1/3 capital B times H. Our base is a square, so that's side squared times your height divided by 3. We have to solve it because here's our 50 there. We have to solve it for H now. We know that S is 5 because that's what we get right there. So now we go 50 equals 25 times H over 3. I want you to solve it just like we've been solving the other ones. Yesterday we learned that if we have the cylinder volume, we can divide it by 3 to get the cone that has the same radius and height. So if we have the cylinder, we can divide it by 3 to get the cone. But what if we have the cone? What would we have to do to get the cylinder? It's not divide by 3, it'd be the opposite. So I want you to do that. Here's our cone volume, and do what you have to do with the 3 to get the volume of the cylinder. Number 6, a solid can be constructed with 2 congruent triangles and 3 rectangles. What is the name of the solid? I want you to give me the name of the solid for number 6. We're going to omit number 7, and we're going to omit number 8. Now we're going to move to 516, and they talk about surface area and volume, but there's one thing in 516 that we haven't learned yet, and I want us to look at it. So skip all the way over to page 626, and we're going to look at it. Now, it kind of says something, you know, a little unusual, talking about put an elephant in a sphere. Let's just talk about a sphere, okay? Remember, a sphere looks like this, looks like a ball, okay? And here are the volume and surface area. You may have that on your formula sheet you should have. I know you have the volume. I'm not sure if surface area is on there, but this is how we do it. So it says, let's model an elephant with a sphere that has the radius of 4.5 feet. This is the radius. What is the volume of the elephant? So we're going 4/3 times pi times 4.5 cubed. Don't square it like when we do a circle. This is a sphere. So now, in your calculator, you could do this. 4 times pi times 4.5 cubed, get that, divided by 3. Do that, tell me what the volume is. Now, the surface area is 4 times pi times r squared, because we're talking about area. So we're going to go 4 times pi times 4.5 squared. Do that, and let's find the surface area of that sphere. Don't worry about number 2. Let's go to purple pages. It says these solids all have the same volume. Which has the least surface area? So which one of those would take the least amount of paper to cover if we had to wrap it? So let's discuss that and think about it and tell me which one has the least amount of surface area. And that is the only one I want you to do from this purple pages. Don't forget to go do your cool down and make sure you have your quick check done. Be ready for the quiz tomorrow that's all about volumes of solids.